So let us now start this differential equation. It will be just an introduction for us today. So what is a differential equation? A differential equation is a mathematical equation that relates a function with its derivatives. So if a function is like this, say y is a function of x, y is a function of x, that means there are two variables, x and y. X is the independent variable and y is the dependent variable. So the derivatives will be like this, dy by dx. If it is of the second order, then it will be d square y by dx square, etc. So if in an equation there are the variables and along with the derivatives, say dy dx, d square y by dx square, etc. are present, so in that case we say that this equation is a differential equation. So in applications, these functions usually represent physical quantities. Yes, force acting on a body, population of a country, etc. Current in electric circuit. These type of physical quantities involved. If you want to write down the equations governing the system, then you will get a differential equation. So in physical problems, we often need to solve these type of differential equations. The derivatives represent the rate of change of the functions. Yes, if your function is y as a function of x, dy dx means what? The rate of change of the functions. And the equation defines a relation in between the two. So if the function in the differential equation has only one independent variable, we get an ordinary differential equation, which is in short denoted by ODE. ODE means ordinary differential equation. An ordinary differential equation involves only two variables. One is the independent variable, normally we take it as x, and the dependent variable as y. But in partial, if you have more than two variables, say 3 or 4 variables, in that case the derivatives will not be ordinary derivatives, they will be partial derivatives, and the concerning the associated equation will be partial differential equation. And in this course we will do only ordinary differential equation, not PDE, the partial differential equation. So there are some examples here. You see, ordinary differential equations. You see, there are only two variables, y and x. So you see, this term contains the derivative dy by dx. This term contains the derivative dy by dx first order, 5y equal to 6x. So this is a differential equation, and it is ordinary differential equation. Another equation, you see here, there are two terms containing the derivatives. This term contains the first order derivative, and this term contains second order derivative. So this is second order differential equation. And these are partial differential equations because here the number of variables are more than 2, x, y, and z. Here z is the dependent variable which depends on x and y. Okay, and the partial derivatives are this, del z by del x, del z by del y. Here it is second order, del square z by del x square, del square z by del y square. So these two equations are not ordinary differential equation, they are partial differential equations, and these two are ordinary differential equations. Now let us define two things very important, the order and degree of an ordinary differential equation. What is the definition of the order? The order of the largest derivative. Largest derivative means the largest order derivative appearing in an ODE is called the order of the ODE. So let us go back to the equation here. Take the first equation. What is the order of this derivative? There is only one term here. Will you please tell me what is the order of this derivative? Any one of you, please tell me.
First order.
First order. So the order of this equation will be 1 because here there is only one term containing the derivative, and this derivative has the order 1 because it is first order derivative. So the order of this equation will be 1. Okay, and the degree of the largest derivative is called the degree of the ODE. Order and degree are totally different thing. Order means the order of the derivative, and degree means the degree, the power of the derivative. So degree of what? Of what? Degree of what? Degree of the largest derivative. Here the degree, there is only one derivative and the degree is 1. So this equation has the degree 1 and order 1. And in the second equation, the degree order is 2 because the largest order is 2. This is second order derivative, this is first order derivative. So the largest order is 2. So that's why the order of this ODE is 2. And what is the degree of this largest order derivative? The power is 1. So the degree is 1. So this equation, this ODE has order 2 and degree 1. Okay, so here we have two more. Here we have two more examples. Look into this. See, you please answer me. What is the order of the highest order of the derivative here? Please tell me, what is the highest order here? This
Third
is
order.
Huh?
Third order.
Why third order?
No, Miss,
This
second
is
order.
not the order. This is the power of this derivative. This is the degree.
Second order.
Second order, yes. The highest order is 2. The highest order is 2. So the order of this ODE is 2. And what is the degree of this ODE? It will be 1 because the power of this highest order derivative is 1. Here the power is greater than the power here, but this is not the highest order derivative. This is dy dx. This is first order derivative and this is second order derivative. So this is the largest order derivative. Here the power is 1. Here the power is 1. What is the degree of this derivative? The power is 1. You see, no power means power is 1. Here the power is 3. The power of this, the degree of this derivative dy by dx is 3. And here the power of this derivative is 1. And the definition was the degree of the largest derivative. This is the largest derivative and the degree is 1. So the order of this equation is 2 and the degree is 1. Now look into this. Which one is the largest order derivative? Tell me.
4.
It's 4.
So the order of this equation will be 4. Now tell me what will be the degree?
2.
2. Because here this is the largest order derivative and the power is 2. This is the power here is greater, it is 5, but this derivative is not the largest derivative. It is the first order derivative, it is the fourth order derivative. And here the power is 2. So the degree of this equation will be 2 and the order will be 4. Here the independent variable is t. Independent variable is t. I think there is a mistake here. It should be x, not y. Because there is no y here. The independent variable is t and the dependent variable is x. X depends on t. So there cannot be y here. It should be x here. Please make the correction. It will be x here. So here the order of this equation is 4 and the degree is 2. Okay, now let us have another definition which is also very important. Linear and non-linear ordinary differential equation. So what is the definition of linear ODE? In a linear ODE, the following conditions must be satisfied. The dependent variable and all its derivatives are of first degree. Suppose your dependent variable is y and independent variable is x. So in the equation, the dependent variable and its derivatives, the dependent variable means y and its derivatives means dy by dx. It may be second order, it may be third order, okay? They should have degree 1. They should have degree 1. The coefficient, and this is the second condition, the coefficient in each term containing the derivatives is a function of the independent variable only. The coefficient in each term, that means the term which contains the derivatives. The terms which contains the derivatives should have the coefficients involving the independent variable only, not the dependent variable. So we have some examples here. At first, you decide What is the order of this equation? Order is 3.
Third order.
Third order, yes. And now check whether it is linear or non-linear. You see, what are the degrees of this derivative? The degrees of
One.
both the derivatives are 1. So it is okay. And the dependent variable is y, and here the power of y is 1. So it is okay. The first condition is satisfied. The dependent variable and all its derivatives are of first degree. Yes. So the first condition is satisfied. The dependent variable y, it has the power 1, and the derivatives, both of them have the power 1. So the first condition is satisfied. Now look into the second. The coefficient in each term containing the derivatives. Here, these two terms contain the derivatives, this term and this term. What are the coefficients? Coefficients involve only x, the independent variable. There is no y in the coefficient. So the second condition is also satisfied. So this equation is a linear equation. It is a linear ordinary differential equation. Now look into the second. You see, dy dx is first order derivative and the power is 1. So it is okay. But here, this y is the dependent variable. Here x is the independent, y is the dependent variable. And the power of this y is 2. It is not 1. So the first condition is not satisfied, because in the first condition, what was it? The dependent variable should have degree 1. The derivatives should have also degree 1. So the first condition is not satisfied for this term. So this is a non-linear equation and it has the order 1. Now this next one. Now the next one, you see, dy dx. It is the only derivative and the order is 1. So the order of this equation is 1. And your dependent variable is y. Dependent variable is y. Degree of this derivative is 1. And there is only one term containing this y, and the power of y is 1. So the first condition is satisfied. Now what is the coefficient of this derivative? It is x. There is no y here. So the second condition is also satisfied. So that's why it is a linear equation. Now go to the next one. You see, there is only one term containing the derivative. The order is 1 and the degree is 2. So the order of this equation is 1, degree of the equation is 2. And now check whether it is a linear or non-linear. There is a term containing y. The power of y is 1. So this term is okay to be linear. But this term, this derivative has the power 2. So the first condition is not satisfied, because in the first condition, the dependent variable and all its derivatives should be of first degree. But here the derivative is of second degree. So the condition is not satisfied, and so it is not linear. It should be a non-linear equation. Now, the last one, you see, order is 2. The degree of the derivatives are 1. The first condition is satisfied, but the second condition is not satisfied, because here the coefficient of this derivative is x cubed. So it is okay. But here the coefficient of this derivative is y. But the condition was that the coefficient of the derivatives appearing in a term must be only involving x. The coefficient cannot involve any y. But here the derivatives, this derivative contains the coefficient y. So the second condition is not satisfied. That's why it is a non-linear equation. So the definitions are complete. Now we will discuss some mathematical models which we face in our daily life problem. So at first comes the population dynamics. So there was a theory of Matthews, and the theory is this: the rate at which the population of a country grows at a certain time is proportional to the total population of the country at that time. So if you denote the total population at a time t by pt, so p is the dependent variable and t is the independent variable. So according to this theory, the rate of change of this population, that means dp by dt, the rate of change of this population of a country grows at a certain time is proportional to the total population. So this is the rate of change of the population dp by dt, and it is directly proportional to the population at that time. Okay, so this is your relation coming from the theory. dp by dt is directly proportional to p. So if you convert it into equation, it will be dp by dt will be equal to some constant into p, and this is a first order differential equation. So you see, according to this theory, you are getting a differential equation which will help you to find the rate of change of the population growth of a country at a certain time. Next comes radioactive decay. These are some examples in our real life problem which gives you differential equation. Radioactive decay. So what is the definition? In many atoms, the combinations of proton, you know, in an atom there are proton and neutron in the nucleus, you know it. So the combinations of proton and neutron in the nucleus, which is called nuclei, protons and neutrons together, they are called nuclei, are unstable. They decay. Decay means that these atoms transmute into atoms of another substance. Such nuclei are said to be radioactive. So this is the definition of radioactive decay. To model the phenomenon of radioactive decay, it comes from the theory of physics. It is assumed that the rate dA by dt at which the nuclei of an atom decay is proportional to the amount AT. AT is what? It is the number of nuclei at a particular time t. This AT, A is the dependent variable, it depends on t. It is the number of the nuclei present at a particular time t. And according to the theory, the rate of change of this number is proportional to the actual number of the nuclei. So again, you are getting another equation from this relation. You are getting, okay, that is it is typing mistake. It should be dA by dt equal to k into A. So another differential equation which is exactly similar to this, exactly similar equation, but the function is different. Here the function was the population function, and here the time the function is what? The number of the nuclei, number function. So please make it correct. It should be A here, not P. It should be A. So we note that a single differential equation. So this is the single differential equation. dp by dt equal to kp, dA by dt equal to ka. Exactly the same equation can serve a mathematical model for different type of phenomenon in real life. For example, equations 1 and 2 are exactly similar except the functions pt and at. Similar type of differential equation. Now comes Newton's cooling or warming. There is another theory coming from physics involving Newton's law of cooling and warming, which states that the rate at which the temperature of a body changes is proportional to the difference between the temperature of the body and the temperature of the surrounding medium. So if this capital T represents the temperature of a body at a time t, and Tm the temperature of the surrounding medium, then according to this theory, dt by dt, that means this is capital T, this capital T is the dependent variable which is a function of small t. So the rate at which the temperature of a body changes, that means dt by dt, d of capital T divided by d of small t. This is the rate at which the temperature of the body changes. It is proportional to the difference of the temperature of the body and the surrounding medium. So this dt by dt equal to k into t minus t. So another differential equation, you see. Now comes the electric circuit problems. Okay, so you know, in a closed electric circuit, there may be, in total, there may be three things, a resistor, an inductor, and a capacitor. And according to Kirchhoff's second law, it comes from physics. Actually, we are not going into the details of physics, just we have picked up this theory, Kirchhoff's second law of voltage. You see that this is the theory. The sum of the voltage drops across resistors, inductors, and capacitors is equal to the total electromotive force in a closed electric circuit. So let us let us simply recall that the electromotive force may be coming from the battery or generator, etc., produces a flow of current. It produces a flow of current in the closed circuit, and that this current produces a so-called voltage drop across each resistor, inductor, and capacitor. So this is coming from physics. If you want to know the details, you please have a look into the electricity chapter of a physics book. Okay, further, the following three laws concerning the voltage drops across these various elements are known to hold. So these theories are coming from the electricity theory in physics. The voltage drop across a resistor is given by ER equal to capital R into I. This R is a constant which is known as resistance. This capital R is known as resistance. This small I gives you the current, and this ER is the voltage drop, voltage in the across a resistor. This capital R for resistor. Similarly, the voltage across an inductor, it is EL. L is known as the inductance. It is a constant, and it is known as the inductance. So EL equal to L into di by dt. These theories are coming from physics. L is the constant which is known as the inductance, and I is the current. And the voltage drop across a capacitor, it is EC. EC equal to 1 over C into Q. Q is standing for charge. Okay, and you know the relation between current and charge. Current I is equal to dq by dt. So if you use here to get the value of q, so to get q you must integrate both sides with respect to t. So q should be equal to I integral over I dt. So if you use it here for q, ec will be equal to 1 over c into integral of I dt. So these are the relations for the voltage across the resistor, for the voltage across the inductor, for the voltage across the capacitor. These are the relations, and the corresponding equation will be this. According to Kirchhoff's law, the sum of all these voltages across the resistor, inductor, and resistor, it should be equal to the total electromotive force that is mentioned here. So the sum, according to this Kirchhoff's law, the sum of these voltage drops, ER plus EL plus EC, these are the voltage across the resistor, inductor, and capacitor. It is equal to E. This is the total electromotive force. So just put down the values of this ER, EL, and EC. ER was L into di by dt. EL is ER, I'm sorry. EL is L into di by dt. So this term is written first. EL equal to L into di by dt, and ER equal to R into I. Yes, R into I, and EC equals to 1 over C into Q equal to E. So this equation, definitely it is a differential equation, but here this equation involves two dependent variables, two independent variables, I and Q. Oh no, two dependent variables. It should be two dependent variables, I and Q. So if you want to convert it into only one dependent variable, you just put I equal to dq by dt. I equal to dq by dt. So here it will be d square q by dt square. It will be R into dq by dt plus 1 over c q equal to E. And if you want to convert it in terms of I, you can write q equal to this. Integration I dt. Yes. So please make it correct. The equation contains two dependent variables, not independent variables. It should be dependent, not independent. Please make it correct. So this is second order differential equation where the dependent variable is q, and here it is first order differential equation in which the dependent variable is I. You just write this q. In place of q, just write integral over I dt. That's all. Okay. How much minute? Okay, 8 minutes more. So how can you solve a differential equation? Okay, I directly go to this. topic. Suppose you have an equation d square x by dt square equal to 2t. You see, this is a differential equation of second order. You can directly find the solution. You just integrate both sides. If you integrate both sides, you just write this d square x by dt square like this, d dt of dx by dt. This second order derivative can be written like this, d dt of dx by dt. It will give you this second order derivative, and you are integrating both sides with respect to t. So 2 into integral of t dt. So after integration, you see this is a derivative and this is an integration. So ultimately it will give you simply dx by dt. Because d dt means a differentiation and integral of dt, it means an integration. You know, differentiation and integration are inverse processes. So this differentiation and this integration cancel each other. You will be left only with dx by dt. Dx by dt, after integrating, it will be t square by 2. So 2 to cancel out, just t square. And this C1 is the arbitrary constant coming for integration constant. So to get the value of x, you have to integrate it again. So integral of dx by dt equal to integral of t square dt plus C1 into integration of dt. Now, you see, this is a differentiation and this is an integration. So ultimately, this differentiation and integration, they cancel each other, and you are left with the function dependent variable x of t. In the right side, after integration, it will be t cubed by 3, and here it will be c1 into t plus another arbitrary constant C2. So this is your solution. Here the two parameters are the C1 and C2. For any value, these are constants, for any value of C1 and C2, this differential equation will be satisfied. You can take it. You just find dx by dt and this d square x by dt square. You will see that this equation is satisfied. Okay. And if you are given an initial condition, initial value problem means if you are given an initial condition. So I have done the same math, same differential equation. It was d square x by dt square equal to 2t. And these are the initial conditions given to you. X of 1 equal to 1. What does it mean? It means when x is a function of t, you see, t is the independent variable and x is the dependent variable. So when the value of t is 1, when t is 1, the value of x is 1. And the value of this derivative dx by dt, when t equals to 1, the value of this derivative is 2. So these two are the initial conditions given to you. If the initial conditions are given to you, in that case you can find the particular solution by getting the value of the C1 and C2. Here these were any two solutions. You know, for any value of C1 and C2, this equation will be satisfied. So here I have, in the first step, I have taken C1 equal to 2, C2 equal to 3. It is a solution of course. In the next solution, I have taken C1 equal to pi and C2 equal to 4. These two will be also a solution. But if initial conditions are given to you, can find particular solution. Okay, so this was our solution. We found it earlier. Now to find the value of C1 and C2, to get a particular solution of this equation, you just use this initial condition. So at first, let us differentiate it. Dx by dt will be equal to t square. 3 will cancel out, t square plus c1. Yes. And you know that dx by dt, when t equal to 1, the value is 2. So just put down t equal to 1 here. In the left side, dx by dt, when t equal to 1, in the right side, it will be 1 square means 1 plus c1. And the value of this is 2. So ultimately, it will be 2 equal to 1 plus c1. So c1 equal to 1. You see, you are getting the value of c1. And here, so you just put down the value of c1 here. So c1 will, xt will be t cubed by 3 plus t plus c2. Yes, plus t plus c2. Now you use the first condition, when t equal to 1, x is 1. When t equal to 1, x is 1. So x of 1 is 1, and here 1 by 3. Just put t equal to 1. So 1 by 3 plus 1 plus c2. So the value of this 1 and 1 cancel out. The value of c2 will be minus 1 over 3. So your particular solution for this initial condition. If it is given to you, the solution will be t cube by 3 plus t minus 1 over 3. Okay, and I think this was the last example. So let us have it now. Falling bodies. You know, it comes from the Newton's second law that the net force acting on a moving body, the net force acting on a moving body is proportional to its acceleration A. F equal to ma. This is the very famous second law of motion coming from Newton in physics. Second law of motion, it is force equal to mass into acceleration. And if you apply it on a falling body, suppose that a stone is thrown upward from the roof of a building. So if you assume that no force is acting on the falling stone other than the gravity, so if there is no force other than the gravity, then this force F will be equal to minus mg. Why minus? Because the upward direction is taken positive direction and the direction of this G is downwards towards the center of the earth. So if there is no other force other than the acceleration due to gravity, so not accelerations, I'm sorry, other than the gravity, in that case, F will be equal to minus mg. We know it. F will be equal to minus mg. And if st is the position of the stone related to the ground, so from the ground, if it is at a height of st, at a time t, then the velocity is v equal to ds by dt, and the acceleration will be, acceleration is a here in this equation. So the acceleration a will be, just take the derivative again with respect to t, it will be d square s by dt square. So let us put down the value of a and this f in this equation. So in the left side, you have minus mg, and in the right side, you have d square s by dt square. Cancel out. So d square s by dt square equal to minus g. So this is the famous equation for a falling body. It is the equation for a falling body. And here,
Ma'am,
our time is over actually. You can have
yes,
a look
we
for
have a
this.
class actually.
Yes. I'm ending it now. You just go through it by yourself. If these two initial conditions are given to you, you can find a particular solution, and this is the particular solution: s t equal to minus half gt square plus v naught t plus s naught. This v naught and s naught are coming from the initial condition, and this is a very famous formula for a falling body in elementary physics. So that was the end of this file, and it was the introduction of differential equation. In our next class on Wednesday, we will have our mid-exam, and in the next week, we will start our differential equation. Okay, so this is the end our lecture today.
Okay, miss. Thank you, miss.
Welcome.
মিড পর্যন্ত যা থাকবে তা তো আর ফাইনালে থাকবে না, তাই না? মিডের পরে
Hopefully, yes.
ওকে মিস, তার মানে আমরা জিলের বুকটা আর কি ফাইনাল পর্যন্ত শুধু
The book on differential equation by Jell, it will be for your final exam after the mid.
ওকে
After the mid. Okay. So do you have any further question for your coming exam? No more question, I think, because I have already omitted two topics from your syllabus. One is application of maxima minima, and the other is Euler's theorem from the partial differentiation. Okay, so please have a good practice on your syllabus.
Ma'am, can you please repeat the syllabus again?
Okay, I cannot.
আরেকটা কথা ছিল মিস, ট্রিকোনোমেট্রি সাবস্টিটিউশনে যদি আমি মানে ট্রিকোনোমেট্রি সাবস্টিটিউশন না ধরে অন্যটা ধরি, তাহলে কি মানে ভুল যাবে আর কি? এটাই আমার কোশ্চেন ছিল।
আচ্ছা, এরকম যদি হয়, if it is in the question mentioned that use trigonometric substitution, তোমার যদি কোশ্চেনে থাকে যে just perform the integration, just evaluate the integral, in that case it is totally up to you. It is up to you. Whatever method you choose, it is up to you. But if it is mentioned that use trigonometric substitution to evaluate this integral, in that case, your substitution must be a trigonometric substitution.
Okay, miss, thank you.
Okay. So let us end our class here.
তুমি সিলেবাসটা একটু আবার রিপিট করো প্লিজ কাইন্ডলি।
আচ্ছা, রিপিট করতে গেলে তো এখন আমার বই আনতে হবে।
আজকে যা পড়েছেন তা কি
সেকশন গুলো পেতে চাও নাকি? আমি তো বললাম জাস্ট তোমাদের ক্লাস টেস্টের সিলেবাসে। ওকে, আই এম ব্রিংিং দ্য বুক। ওয়েট এ মিনিট, ওয়েট এ মিনিট। So the sections and the exercises are 4.2, 4.2. Okay, I am omitting another section for you. 4.4. 4.4 and 4.5. These two sections are omitted. So, are you listening to me?
মিস তাহলে
Yes,
তিনটা
ma'am.
বাদ দিলেন
4.2 for maxima
ma'am.
and minima. For maxima and minima, only 4.2.
ওকে মিস
Okay, ma'am.
Okay, only 4.2. Now, for partial differentiation, it was in chapter 13. Chapter 13. Just a minute. Thirteen point three. 13.3. 13.5. Yes. From partial differentiation, 13.3 and 13.5. So from maxima, minima 4.2, from partial differentiation 13.3 and 13.5. And the integration, whole integration will be there. It starts from, I think it starts from what? It was starting from
7.2 থেকে
7.2.
7.2. It started from 7.2, I think, yes.
Yes, miss, 7.2 থেকে 7.5
হ্যাঁ, 7.2, 7.3, 7.4 and 7.5. Yes.
ওকে মিস
For integration 7.2, 7.3, 7.4 and 7.5. And from 7.5 you have to do, I have already told you, you start from, yes, you start from, I think you can start from question number, from question number 20. Yes, you can start from question number 20 up to 34. For 7.5, question number 20 up to 34.
এই 7.4টা একটু বলবেন?
ওকে, 7.4 থেকে বলতে হবে আবার? এগুলো তো আগেই বলেছি আমার যতদূর মনে পড়ে। আচ্ছা দাঁড়াও। ও, 7.4 থেকে তো আমি মনে হয় সবগুলোই দিয়েছিলাম। So you can start from 4 up to 26. আমি কোনটা বাদ দিই নাই তো?
প্র্যাকটিস প্রবলেম বলে
আমার এখন মনে নাই, এটা মনে হয় আমি বাদ দিয়েছিলাম বোধহয়। দাঁড়াও, 19 আর 20 এই দুটো বোধহয় বাদ ছিল। 12, তারপরে 19, 20 এগুলো বাদ ছিল। এটা তো নিয়মগুলো তোমার জানতে হবে, তাই না? 4 up to 26, ম্যাক্সিমাম যে 9, 12 তারপরে তোমার আরেকটা কোনটা 19 20 এগুলো বাদ ছিল 12 19 20 এই তিনটা বাদ ছিল ঠিক আছে so I am ending our class now thank you so much
মিস রেকর্ডিংটা অফ করে দেন মিস
হ্যাঁ ও
রেকর্ডিংটা অফ করে দেন